Thank you, Dennis, and thank all of you for coming out to the lecture tonight. As Dennis said, my talk tonight's not going to be the usual. If you've heard me speak in the past, it's been a lot of bloom and doom about what's happening to our seagrasses and coral reefs and our fisheries in South Florida. So I'm going to mix it up tonight and talk about something I did a long time ago. And it involves a very unique part of our blue planet, the legendary Sargasso Sea. And this work I started on back in the early 80s, as Dennis noted. I had to dig pretty deep in my archives to dust off some old Kodachromes and video to share with you tonight, these secrets I'm going to reveal. And in doing so, it's very disturbing to realize I used to have hair. You're going to see that in the photos and video tonight. So, without further ado, what I'm going to talk about, a little bit about the history of this mysterious region, the Sargasso Sea, the discovery of the sea, the early oceanography of the sea, some of the mysteries that remain about this region of our blue planet. And then a little bit about my science, the research I did, carrying on from John Ryther's seminal work on the productivity and nutrition of the algae that grow in the Sargasso. And then a very special treat tonight, first time ever, I'm going to share with you footage from an NHK show, The Universe Within the Sargassum. This was one of the early H.D. NHK broadcast shows in Japan. They came here and I led them on an expedition to this Sargasso back in the 90s. Never before seen in the United States, this footage. Also, we're going to talk about a little bit about the Sargassum in the Gulf of Mexico, issues emerging there, and wrap up with the impacts of the Deepwater Horizon oil spill this past year. Okay, well, the Sargasso Sea was really first described by Christopher Columbus and his sailors making the first transatlantic voyage to the New World in 1492. They encountered this mass of floating vegetation, these brown seaweeds, as they moved west from the Azores. And Columbus's sailors gave them their name, and this sea, the name Sargasso Sea, named after the word salgazo, which in Portuguese means grapes. Because as you'll see, the little air bladders on the plants reminded them of grapes. Well, the Santa Maria and sister ships were actually becalmed in the Sargasso area for 3 days. The sailors got pretty nervous. They thought they were running up on a mid-ocean reef. We're going to sink and be stranded. And through the centuries, this whole graveyard legend has grown and actually has become established. Now, a lot of this is myth, but you're going to see tonight that a lot of real mysteries still remain about the Sargasso Sea. Well, the plants for which the Sargasso Sea was named are comprised of 2 species. Now, we refer to pelagic sargassum. Pelagic means floating. Benthic means attached to the bottom. And there are only 2 species of pelagic sargassum that sustain themselves in the Sargasso Sea, Sargassum fluitans and Sargassum natans. Sargassum fluitans is the large-leafed plant, and Sargassum natans, the more delicate, narrow-bladed plant. Sargassum natans also has a little apical tip on its air bladder, and you can see the air bladders on both plants. It allows these plants to float, and we call it a holopelagic existence. These plants live their entire life cycle floating on the surface of the Sargasso Sea and surrounding water bodies, and they have no sexual reproduction. They reproduce solely by vegetative fragmentation, and they're actually unique among algae in that a lot of algae have very complicated life cycles. Okay, the Sargasso was defined early on by explorers by the boundaries of where the Sargassum was or was not. And for example, Humboldt in 1814 described what he called the Fucus Bank, shown here, these little line drawing, because the Sargassum vegetation reminded him of fucus, which is a brown seaweed, looks very similar, but it grows intertidally, both in Europe and in North America. A few years later, Maury created a similar map of the Sargasso, again based on the abundance of this floating seaweed. But the first real quantitative study or scientific study of Sargassum was conducted by Albert Parr, shown here in 1933, sailing aboard the research vessel Atlantis. And the Atlantis was, by the way, the original research vessel for Woods Hole Oceanographic Institution, and for many years was the only research vessel supported by the United States to go out and research our oceans. Did a lot of critical work during the wartime years. But Albert Parr sailed over 7,000 miles on the Atlantis, did a lot of collections of Sargassum. You can see what appear to be little aquaria on the Atlantis here, where he was collecting Sargassum and its fauna that lives in the Sargassum, doing studies. He also did a lot of hydrography, looking at the temperature and salinity distributions of the oceans. And based on that early work, that's what really led to our early understandings about the circulation of the Sargasso Sea, the Caribbean, the loop current that goes up into the Gulf of Mexico, the Florida current, and the Gulf Stream. And it was some years later that my mentor, John Ryther at Woods Hole, published a review in the American Scientist Journal. This is 1956. John was a scientist at WHOI at the time, and pointed out in this article that the Sargasso Sea is really defined in modern terms by the boundary currents that surround it. The Gulf Stream to the west, the North Atlantic Current to the north, Canary's Current to the east, and the North Equatorial Drift to the south. John also pointed out that this body of water was lens-shaped. It was warm water sitting on top of cooler water. The 10-degree centigrade water was about 800 meters down below the surface, and it was lens-shaped and actually higher in the middle of the sea, about at least a foot to a meter higher in the middle of the Sargasso Sea than around its edges. And it's also the only sea on our planet that does not have shores. Well, let's take a little flyover with the help of Google Earth and just fly on out there to the Sargasso. We're going to start from Harbor Branch. You all recognize the ship channel. And we're first going to go to Bermuda, where I staged some of my research in the Sargasso Sea. We're coming down now at the Bermuda Biological Station. In fact, those of you who remember the Edwin Link, that's where the Edwin Link is now stationed. Okay, we're beaming over to Puerto Rico now. This is the old fort, San Juan. And now we're going to fly back to Harbor Branch. So this is an area we've just flown over that encompasses the Sargasso, and here's the Ed Center right here. Okay, let's beam back up, get a satellite view of this area we just flew over. And I think many of you recognize, if we connect the dots, this is an area commonly known as the Bermuda Triangle. Now, I've defined the western corner of this as originating right here at Harbor Branch, because this is the most mysterious place I've ever seen. But you'll see others define it in other ways, okay? But what I'd like to do now is share with you the fact that indeed there are real mysteries that remain about the Bermuda Triangle, which I call the Harbor Branch Triangle. Okay. This is a BBC clip.
This is Fort Lauderdale.
Do you read me?
FT28 to Fort Lauderdale. Do you have a fix yet?
The myth of the Bermuda Triangle began on the 5th of December 1945, when a group of 5 aircraft mysteriously disappeared.
Everything is wrong.
Even the ocean looks different.
Flight 19 was a routine training mission of 5 Avenger torpedo bombers. The 3-seater Avenger was the US Navy's top ship and submarine killer. It could carry up to 2,000 pounds of ordnance and had a range of 1,000 miles. The Avenger was robust and reliable. The doomed Flight 19 left Fort Lauderdale at 2:10 on a clear winter's afternoon. 4 hours after they took off, they vanished into thin air. Fearing the worst, a naval air search rescue plane took off into the darkening skies. 20 minutes later, at 7:47 p.m., the rescue plane also disappeared. After a massive search, no wreckage was found. And nothing was ever heard from them again. Until now. Over the last 60 years, this mystery has sustained the wildest theories about what strange forces could be at work out here. Legend has it that the triangle covers the seas between Miami, the island of Bermuda, and Puerto Rico, an area of 1.5 million square miles. Since 1492, when Columbus first sailed into the area and saw strange lights in the sky, the list of unexplainable disappearances in the Bermuda Triangle has grown. Thousands of ships and planes have simply vanished. No warning, no distress calls, no wreckage. Richard Weiner has written many best-selling books about these strange disappearances.
We don't know our own planet. We know more about the moon. We're probably learning more about Mars than we know of our own planet. We know about the Earth, but we don't know about the sea.
The boatyards of Key West hum with stories about those who were lost in the triangle. Stories of giant sea monsters, cosmic time warps, spinning compasses, and holes in the ocean that swallowed ships have echoed throughout the world. Yet the disappearances continue.
I would say there's some kind of a anomaly going on down there that we can't explain. Something that goes on down far, far below the deepest rays, the last rays of sunlight, way down. There's something going on down there.
Well, I wonder what that could be going on deep in the deep blue sea. You know, Captain Jack Sparrow had some ideas. Remember the spinning compass, the rum bottle that he was moving around the compass and the compass would spin? Yeah, they need to test that. That's an idea for a proposal. Okay, well, as those pilots from Flight 19 were flying out over the Florida Current, over the Bahamas and the Sargasso, this is what the Sargassum itself, the seaweed, looked like from the air. These parallel, what we call windrows, that are formed by the wind passing over the surface of the sea. And what happens as wind goes over the surface of the sea, it imparts drag on the surface that causes counter-rotating eddies that lines up the seaweed at the zones of the sinking water. And that's what results in these parallel windrows of the seaweed, Sargassum. This was all kind of reviewed in John Ryther's 1956 paper in American Scientist. And it's named after Langmuir, the physicist who actually first discovered this in 1938, published on it in the journal Science. Now, going back to John's paper, probably the major point John made in his paper was the fact that all the studies John and other oceanographers at the time had done on nutrients and productivity of the oceans clearly showed that the Sargasso Sea was the clearest, purest water ever studied, incredibly blue clarity to it, and that because of the low nutrients like nitrogen, phosphorus, and iron, they termed it a biological desert. That was the very term John used, a biological desert. Well, this is a paradox in oceanography. How do you explain all this productive biomass of seaweed floating around the Sargasso Sea without nutrients to sustain that biomass? So that brought forward a hypothesis from me. I was trying to carry on John's work at the time. So I started looking at the oceanography and the physics of the region, and I thought, you know, there's a lot of physical connectivity between the Sargasso, the Gulf Stream, the Loop Current, the Gulf of Mexico. And I wonder if these populations in the open ocean and the Sargasso aren't being resupplied by fast-growing, nutrient-rich plants that are being enriched as they circulate in these what we call neritic areas or coastal zones. Like this weed line right here. This photo was taken off Savannah, Georgia on the west wall of the Gulf Stream, where you not only have river-borne nutrients coming out into the coastal water, but this little milky substance you see in the water is a little cyanobacterium called trichodesmium that fixes nitrogen, ammonium, and that too can enrich the Sargassum. And once these plants are cruising up the Gulf Stream, we have these features called warm and cold core rings that we discovered back in the 70s when I was at Woods Hole. The warm core rings are Gulf Stream surface water that spin off into the Sargasso Sea. The cold core rings are coastal water. They also spin off. And that can actually transport the Sargassum and the nutrients in the Sargassum out into this biological desert and could explain how these populations sustain themselves. Well, in putting all this on paper, of course, I had to look through the scientific research that was being done at the time, and I found this. Carl Barks' article on the Duckburg chapter of the Junior Scientists of America. They were scooping me. They had already figured a lot of this out. And so what they were proposing to do was to actually go out to the Sargasso Sea and create a seaweed farm out there. Now, at this time, this is particularly interesting because Dennis Hanasak and John Ryther and I were funded by the Gas Research Institute to look into the bioengineering aspects of algal farming for biofuels. And we were looking at Sargassum and the idea of doing major large farms in open ocean environments like this. And here we see the ducklings beat us to it. The difference is the ducklings weren't interested in biofuels. They wanted to use the seaweeds to extract gold from seawater. This is why they called it the Golden Seaweed Farm. And they knew, as we did, that these plants actually get their nourishment directly from seawater. So I wrote this proposal, and this is, of course, me submitting it to the National Science Foundation over here, going, so what? Well, the good news is we got the proposal funded. In fact, it was the first grant to Harbor Branch from the National Science Foundation, 1985, to really kind of look into this hypothesis and see if we could find some evidence for it. So over the course of a number of years, we cruised out to the Sargasso, we flew there, we sailed there with a number of research vessels. These are some of the stations we occupied studying it, all the way from the southern Sargasso, 06, all the way up to the northern Sargasso, 01. And we had neritic stations, N1 to N7, extending from Belize, coming up through the Florida Straits and the Gulf Stream off Charleston, and N7 up here off New Jersey. So these were comparative studies of oceanic stations versus what we call neritic. And we wanted to see how these plants differed between these two areas. These are some of the ships we used. This is all back in the mid-'80s. In fact, it was so long ago, it was before our ships were certified by the UNOLS, the National Fleet, to support researchers. So I was forced to use the University of Miami ships, the RV Callanus, the Columbus Island, Duke University's research vessel, the Cape Hatteras, And in the later years, and with the NHK crews in the 90s, we used our own RV Sea Diver. Okay, on all these ships, we would construct a flowing seawater system in which we could collect the plants with dip nets and small boats, bring them back into tanks that got high volumes of flowing surface seawater from the Sargasso Sea or the coastal areas, and we would monitor their growth. We would weigh them and put them in these cages and carefully watch them over the course of several days. At the same time, we had a whole series of bottles set up on the rear deck, the fantail of the ships, where we had the growth tanks and also all these incubation trays that had running, flowing seawater, water-driven magnetic stirrers. We could have hundreds of bottles out there doing experiments of nutrient uptake, alkaline phosphatase, this enzyme that allows these algae to scavenge phosphorus from low nutrient waters. Well, my students and assistants had so much work maintaining hundreds of bottles every day through the night. This whole system took on a name of its own. It was called the Jarrah Fields. And it was like slave labor, these poor students having to work in the fields monitoring these bottles. But we got a lot of great data, some of which has been published, some yet to be published. You might notice, speaking of these old photos, that's the old Harbor Branch Foundation logo on my shirt there. That picture was about 1983, I think. We also had very sensitive oxygen sensors, an Orbisphere oxygen measurement system that we set up in the black box here, that we could measure very accurately with high replication of all those bottles, the photosynthesis and respiration of the little sargassum plants in all these different locations. And this is what we call a photosynthesis versus irradiance curve, okay? Basically, we're looking at the average of all these measurements in the nearshore stations, here, the higher curve, versus the oceanic stations. And what we see is that these plants are much more productive in these nearshore areas. This was good support for my hypothesis. In fact, this photosynthesis data matched up very closely with the growth rate data. The growth rate data showed that the plants in the nearshore area were doubling in about 20 days. The biomass would double compared to the open ocean Sargasso Sea plants where it took 100 days or more to double. So we took this even one step further and actually looked at the nutrient content of the plants themselves. These are just average values of the sargassum tissue, what we call the carbon to nitrogen ratio and the carbon to phosphorus ratio. That tells us a lot about the nutrition of the plants. And you can see the neritic plants have a lot more nitrogen than the oceanic plants. The ratio is about half that of the oceanic plants. Same thing for phosphorus, even more so, that they're even more phosphorus depleted out here in the Sargasso Sea. And we looked at the seawater itself around the windrows of sargassum in both the neritic and oceanic areas, and you can see ammonium and phosphate, we found very high concentrations in these weed lines compared to very, very low and often undetectable concentrations out in the open ocean. So all this was a lot of evidence supporting the hypothesis that this stuff is really growing in these nearshore areas and is getting carried out to the Sargasso, where it slows down its growth and ultimately can fall to the bottom of the sea. It's kind of like the elephant dumping ground out there. And this was just opposite what the textbooks say. They really were saying that it really grows out there. So we also looked at the fauna, the amazing numbers of invertebrates that are found in the sargassum community. At least 100 species are associated with sargassum. And there are many, many examples of symbiosis in this community. Mimicry, where these invertebrates can mimic the color of sargassum, for example, to avoid predation, like the shrimp leander that takes on the color of the sargassum, the swimming crab, Portunus, the little nudibranch here, Sciella and hydroids, bryozoans, it goes on and on. But what we really began to focus on were the fishes associated with Sargassum, because we noticed where we would find these high concentrations of ammonium and phosphorus was typically around windrows where we saw a lot of fish. And really some of the best examples of symbiosis can be seen in the fishes of the Sargassum community. This is the so-called Sargassum anglerfish, histrio. Now, it not only mimics the color of the Sargassum, but the texture of the skin. Look at these little appendages hanging down that mimic the actual texture of the seaweed itself, okay? This is the foot of the fish. Now, the Sargassum fish is not a very good swimmer. It is adapted as an ambush predator. It sits up in the weed, braces itself with its feet, and lures fish in front of it, and is well camouflaged. And then, as you're going to see in the video, is really a voracious ambush predator. But in terms of numbers of fish, the plainhead filefish, these little guys here, spend their juvenile life history in the Sargassum. We found hundreds of these per kilogram of seaweed. And we did excretion studies and showed that they're really putting out a lot of ammonium and phosphorus. So we have evidence indeed that this particular symbiosis is what we call mutualism. The fish benefits from its association with the seaweed. It gets habitat and protection from predators, and in turn, the fish are excreting nutrients, fertilizing the seaweed, allowing the seaweed to grow. So pretty amazing stuff. A lot of other species we found. This is the little driftfish, a lot of those in these weed lines. Small juvenile barjacks, yellowjacks, very, very common in this community. We also see evidence of layering, that these different fishes associated with Sargassum, some of these are up in the Sargassum canopy. Okay, like the Sargassum fish obviously is relying on that, but the plainhead filefish. But underneath you get this layer of small jacks, carangids, and other fishes that are slightly larger that prey on these fish in the community. And then when you look down below into the deep blue sea, then you get predators that come in and forage on these weed lines. And of course, I know a number of you have been offshore in blue water fishing along weed lines. And how many have been in a boat out there with a school of mahi around you? Okay. Well, you know what a great experience that can be. And these are very fast-growing fish. We were forced to do some fishing during this expedition and do gut analyses. And sure enough, we did verify that the guts were filled with, little crabs and fish associated with the Sargassum community. And is Megan here? Don't know. Megan, I just wanted you to know, because I know you're very focused on seafood safety and taste. We tested the fillets, we ate them, and I want you to know they were excellent. They tasted great. So that was really a lot of fun. Well, it doesn't stop there. These weed lines indeed support a tremendous pelagic fishery in the western North Atlantic. The triple tail, we ran into these guys a lot. We could catch those just with a net, going by in the boat. Sailfish, wahoo, marlin. This is one of those moments when you could use a bigger boat. And in the 90s, after I did a lot of this work and demonstrated the importance of these nearshore convergence zones, which are where a lot of the fishermen focused their fishing efforts, and it wasn't just fishermen, we had companies being formed that were going out and harvesting the Sargassum, pumping it up to make fertilizer out of it and bring it back into North Carolina. This was of great concern because a lot of people think the Sargassum is disappearing and going away. Had a gentleman here in the first lecture who's been here fishing 70 years, and he believes it's really on the decline, as many do. Anyway, I was called to testify in front of the South Atlantic Fishery Management Council to get some protection for this community. And so it has been declared as essential fish habitat, and there are rules about harvesting it and bringing it into U.S. territorial waters. Well, the concern wasn't just for the sport and commercial fisheries at that hearing. It was about the fact that we know that Sargassum is the home of several sea turtle species, most notably the loggerhead turtle. And a wonderful story from my earlier days as a graduate student up at Skidaway Institute of Oceanography was when I was offshore doing some research with colleagues, and we were cruising along the weed lines on the west wall of the Gulf Stream, and we were looking down and we saw these little black masses in the weed, look like this from a distance. We thought they were tar balls in the weed. But on closer inspection, we realized they were little juvenile loggerhead turtles. This was around 1980, and what was so special about this, at that time, Archie Carr, who I think many of you know is the man when it comes to sea turtle conservation, education, and awareness, had published a paper that he didn't know where the little turtles went when they left the beaches of Florida and around the Caribbean region. So we called Archie at University of Florida and said, we think we found your lost generation of loggerhead turtles. Archie, his students and colleagues went on to study that for the next few years and published a paper in Bioscience on rips, fads, and little loggerheads, how that when these little hatchlings leave the beach, they go through like a 24-hour frenzy swimming offshore looking for sargassum. And of course, they're very vulnerable to predation until they get into these weed lines. So Archie passed away in the late 80s. This is one of his last papers. But you can all go up and see the Archie Carr National Wildlife Refuge up in Wabasso area, just south of Pelican Island. It's a wonderful thing to do if you're a fan of sea turtles and Archie Carr. And just a little further north is, of course, Pelican Island National Wildlife Refuge, where the whole National Wildlife Refuge system began back in 1910. Well, other amazing phenomena, probably beyond incredible, is the fact that the European and American eels, adult eels, come from frozen, ice-ridden freshwaters, rivers, estuaries in America and Europe to the Sargasso Sea in January, just like snowbirds, go into these warm waters to spawn and die. And the little glass eels that result from that, of course, come back up the Gulf Stream and find those very freshwater rivers and habitats where they then grow back into adults. But there is so much that remains a mystery about this incredible journey. Well, because of all this uniqueness in the Sargasso Sea, it has recently been declared by GOBI, this is the Global Ocean Biodiversity Initiative, as an EBSA. You like those acronyms? EBSA? EBSA is an environmentally and biologically significant area in our blue planet, one of 4. And the main criteria that has been put forth is the fact that it's unique in the world as the only area that is a center of distribution for a self-sustaining community of this holopelagic drift algae, sargassum, that provides structural habitat for a range of fauna, including endemic, threatened, and commercially important species, and is a spawning site and migratory route for several species such as the eels, marlin, tuna, loggerhead, sea turtles, and humpback whales. Indeed, pretty amazing. And this action was taken because we're setting up marine protected areas to protect a lot of our sensitive coastal areas, such as the Florida Keys, the marine sanctuaries, but relatively little is being done to protect offshore areas. And in this era of climate change, ocean acidification, overfishing, obviously we need to really start thinking about protecting these resources. with that, we're going to move into the main event here, looking at some outtakes from the NHK show that was aired back in the 90s. It's a high definition documentary on the Sargasso Sea that I helped lead this expedition out of Key West out to the Bermuda region on the Sea Diver. This is Captain Ralph. This is the NHK film crew producer. Mr. Wada, the cameraman, here on the left, the yellow towel. John Reed, our dive safety officer. I don't know who this guy is in the blue shirt, but he's got a Harbor Branch shirt on. That's me with more hair back in the old days. And the camera system, the high definition camera. It's a Sony. And you know, they're on to 3D TV now. You know, this was 15 years ago or so. But at the time, this was the state-of-the-art HD camera system, and very, very interesting how this was tethered to the Sea Diver. We had monitors in the aft laboratory, the dry lab. Okay, so you can see what we're doing at this point is we're looking for weed lines. And I think I have a dip net ready to grab some weed. Okay, this is the trajectory of the cruise. We left Key West. We actually drifted up the Florida current and then steamed out to Bermuda. And again, this is the Sea Diver back in 1997. This is a Sargassum watch we posted looking for weed lines. And this is one of the first weed lines we encountered just offshore Key West, heading out to the axis of the Florida current. You can see how the water slicks over in the downstream side as a result of the weed line. This is actually a weed line a little further north, but you can see this trichodesmium I was talking about earlier, that all this soupy looking stuff. This is the cyanobacterium that fixes nitrogen. Now, I had talked to them about the importance of the benthic species of Sargassum over time, over eons, contributing to the evolution of the pelagic species. And this is one of those benthic plants, and this is a little graphic they produced showing how these coastal Sargassum plants can break off and get entrained in the loop current and ultimately, you know, move out towards the Sargasso Sea. But again, the weeds we find out there that sustain themselves are pelagic species. They're not these benthic species. So here we've got some weed and we're shaking it out into a bucket. And it's amazing the amount of life and diversity that can come out of a few clumps of Sargassum. Filefish, triggerfish, jacks. Here's a little histrio right here, little juvenile. You can see moving around the tank. He can't find any weed to hide in. Must be getting pretty nervous about now. The Sargassum shrimp here. And you can see the crabs. Okay, a little close-up of Sargassum fluitans showing the air bladders, and a little cameo appearance here on the film talking about the ecology. Okay, now I think this is the cameraman and John Reed entering the water. And they're going to go under, and I think this is one of the patches we selected for deploying, as you'll see in a minute, a big artificial reef. Here comes the camera underwater, this stainless housing. Okay, you can imagine what this would look like in high definition. And you can just see this patch teeming with life. A lot of the fish up here right in the canopy, but a lot of them underneath. Again, that kind of layering effect. But what you can't see are all the very small larval and very early life history fishes that are found in this community. And you really need a fine mesh, plankton mesh net to be able to collect and quantify those. These are some white-spotted filefish here. And the scrawled filefish moving around. Now, some of these very close-up shots we actually shot at my lab, Bell Lab on Big Pine Key, where we had really good controlled conditions and no vibration that we had on the sea diver to get these really tight-in shots. And as I mentioned, we see a lot of carangids or jacks associated with these weedlines. I think here's a little drift fish. Okay, this is a little shot here panning across a blade of Sargassum showing some of the invertebrates, okay? Hydroids, bryozoans, and here we go. This is really unique footage you're gonna see now. This is Histrio trying to find a launch pad in the weed lines. There's his foot. Now watch this as he places this on a blade of Sargassum at the resemblance of the Sargassum to his foot. That's what he braces with. You can see he's got like an elbow, okay? That's highly adapted for these ambush predators. Okay, here's looking at you. I'm glad they don't get any bigger than they do, I'll tell you what. Watch this. Here it is in slow-mo again. And this one is a really great clip here. This reminds me of my Chihuahua. You think he bit off a little more than he can chew? Well, as the story goes, if you put a bunch of these fish from Sargassum in a bucket, the largest Sargassum fish will be the last fish standing. And here is the mating behavior of a male on the bottom and a female. I don't think this footage has ever been aired in the United States. Okay, here's the female getting ready to lay eggs. She's being assisted by the male. This is true love now. And here's the egg mass, okay, that she just released, gets fertilized by the male. And he lifts her up higher in the water column, which releases the eggs. It reduces the pressure on. And here's the egg mass. And a couple more shots just showing the behavior of the shrimp in the weed, feeding on different things in this pelagic environment. And again, some of the invertebrates, the anemones, we find patches of this pelagic sargassum that have like blooms of the little sargassum anemone you're seeing here. And again, so many larval forms of shrimp and amphipods, isopods, copepods that live in and on the Sargassum. This is the goose barnacle, commonly found in the weed lines. And these crabs. Okay, there's Jerry Corsall. I think he's here. Jerry is in the back. We're deploying an artificial reef off the stern of the sea diver at this point. The idea was to mount the camera under this kind of artificial Sargassum reef and be able to film continuously through the night to see what might just be attracted to that FAD or fish aggregating device, all this seaweed. So we're getting the camera ready to go underwater and mount it to the artificial reef. So we have some underwater gaffers and grippers involved here, mounting the camera to the structure. It actually goes up into the raft and an inverted tripod. And you can see the sargassum that we tied to the structure with a net, kind of wove the sargassum through the net so that it would secure itself around the frame. And then from the dry lab on the sea diver, we could pan and tilt the camera. We had lights to illuminate it to be able to see what might appear. And what's the first thing we saw? Mahi, another one. And not long afterwards, a school came in. And this is some footage of a mahi actually feeding up in the weed, slow-mo. So and of course this community gets hammered by predators from below and above as well. A number of seabirds feed in and around pelagic sargassum, petrels, and terns. And this guy here is really giving those fish the business. Okay, nighttime shot. This is a triple tail coming in, finding refuge under the weed line. And flying fish, which also lay eggs right in the sargassum itself. And for those of you who don't know, they don't really fly, they glide. They don't flap their pectoral fins like birds. And the swimming crab, you have to be able to swim if you're going to be part of this community. Well, we made it to Bermuda, and we sailed in, and one of the things we wanted to do in Bermuda was to check out one of the early harmful algal blooms that I studied, a big bloom of invasive algae there. This is some of the local attire, Bermuda shorts. And we went diving in Harrington Sound. This is this invasive green seaweed, Cladophora prolifera. Of course, its name speaks for itself. And it covers the whole bottom of Harrington Sound, just acres and acres of it, up to a meter thick or so. But there are a few areas in the Sound that contain some very significant marine life. This particular lobster must have gone 15 to 20 pounds. And that was pretty amazing. So we left Bermuda and we're sailing back now to the west, looking for more weed lines as we go. And actually we didn't find too much in the Sargasso until we got to the Gulf Stream. And there it was. Again, looking very well nourished as our experiments. And on our way through Florida, there is where we saw little loggerheads swimming out to their safe spot. Always looking for these predators, the oceanic white tips. They account for more attacks on humans than all other species of sharks combined. And there's a turtle up in the weeds, again, trying to protect itself from predators like sharks. Or these guys, alligators. Now, I've never seen an alligator in the weed line, but I wanted to bring your attention to this particular alligator that was filmed in 80 feet of water off Boynton Beach last year. But if it's in that area, it certainly could go up into the weed lines. And last but not least, the spotted dolphin here, festooned with sargassum. This is shot over on the banks just to the east of us in the Bahamas. The sandbores. One of the things I'm working on now, as a result of kind of what's happened in recent years, is the Gulf of Mexico, our Gulf. And one of the issues that's developed is a problem of excessive amounts of sargassum stranding on beaches. We've had a problem along the Texas coastline with massive amounts of sargassum piling up on the beaches. It's become a real problem for local governments, having to treat this as solid waste and hauling it off to a landfill or burying it. There was an issue on the west coast of Florida with an 80-mile long patch of sargassum coming down the loop current and then being blown ashore and clogging the intake of the Crystal River power plant. Almost caused a China syndrome. And I got a call down in the Florida Keys where I was at the time, and they were going to fly me up. They thought I could do something about it. I said, I study sargassum, but I can't help you with this problem. And anyway, the headlines of the Miami Herald read, "Seaweed brings mighty machines to halt." Anyway, the revenge of the sargassum. And that's that slide right there. Anyway, what we think is going on in the Gulf of Mexico is, and I think most of you know, we have a real problem with the nitrogen in the Mississippi River coming from the heartland, from fertilizers coming down and creating our largest dead zone in the United States. And all this nitrogen and the plume of the Mississippi coming out, this is a shot of it, moves to the west towards Texas. And here's a satellite image showing it. It's actually grown to an area of about 8,000 square miles, about the size of Rhode Island in 2005. We think what's going on is that the sargassum is becoming fertilized as it mixes with this water and nutrients in the greater circulation of the Gulf. And we have a small grant now from NASA to actually monitor this from space with the use of satellites. My colleagues at the University of South Florida have developed an index, the Floating Algae Index, that allows us, these are actual weed lines here in the Gulf of Mexico, this region right here. And we've realized that a lot of this algae is ending up in the western Gulf of Mexico as it moves west from the Louisiana area. So we're trying to communicate with the people in Texas to let them know when to get the bulldozers out, that the algae is coming. Now, the other issue that emerged this year was the Deepwater Horizon oil spill. And this became a real problem for sargassum that was circulating through that area. This particular shot is of a burn box where the responders and the cleanup were actually going out and burning the oil. And in many cases, this oil was on sargassum where they were burning not just the oil, but the sargassum and the associated fauna. It's a real problem for sea turtles, obviously, endangered species that were already having a problem before the oil spill. An article, Death by Fire, appeared in the LA Times, and a couple other articles were written about that. But as you know, this year, the models that came out early on were predicting that the loop current was going to carry this oil around the Florida Keys and up the east coast of Florida. By several months, we thought that was going to happen. Everyone was really kind of banking on it. Well, it never happened. But we were very concerned because we knew by the time it got to the East Coast, it would be not in the form of oil slicks on the surface, but as tar balls due to the weathering of the oil over that great distance. So we got a small grant from the Harbor Branch Foundation to go out and monitor using a Newston net, looking for tar balls, because the concern was sea turtles coming off the beach in late summer would encounter these weed lines and potentially ingest these, thinking they were food items. And they can be toxic to turtles. That's been documented. So there was a real concern about that. We did find some tar balls. This is one of them. They're going to be analyzed to see if we can match them up with the Mississippi Canyon oil. If it was Mississippi Canyon oil from the Deepwater spill, this would be probably the most far field effect of that, but we don't think that's going to turn out to be the case. And the reason we saw very few tar balls was because of our friend, Eddie Franklin. This was an eddy that formed in the Gulf this summer that really kept the oil and the tar balls in the Gulf of Mexico. This is sea surface height, and this is high water. We're looking at probably a half a meter higher water right in this eddy here than the surrounding water. And what happened is that the Yucatan Channel here is basically cut off from the loop current. It would normally come up like this, but it short-circuited the Gulf and just started flowing towards the Keys. So we were kind of getting clear blue Caribbean water this summer rather than the loop current water coming down from the Gulf. And so that really helped us dodge that bullet. This year has been kind of coming full circle for me, not only working with sargassum again, but oil pollution. And after doing this work, I realized the first paper I ever wrote was called Oil on the Sea. 1973 as an undergraduate at Boston University. I wrote this, published it in the journal Aquaspheres, the journal of the New England Aquarium. And it was amazing to read the last two sentences of this article, where I noted that the public in most nations back then, including the Iron Curtain nations, regard oil spills as intolerable, and that if the industry doesn't manage to develop adequate means to deal with them, the public must demand that additional restrictions be placed on the industry. Well, we saw a lot of that going on last year through various forms of media. So what I wrote decades ago clearly spoke very well for the state of the industry last year. And another great thing, and this is kind of saving the best to last, I did get to work with some new students from FAU, both of whom are doing their master's research on different aspects of the ecology of pelagic sargassum. Chelsea Bennis and Lauren West here on the Mysterios off Key West. Chelsea just defended her thesis proposal last week. Lauren's is going to be in the next month or so, but they're going to be doing some really interesting work on this community in the near future. And just want to wrap up and thank the National Science Foundation, NASA, the agencies that have supported a lot of this work, my colleagues at the Smithsonian, the Bigelow Lab up in Boothbay, Maine, University of South Florida, for all their support, and a lot of people over here on the side that have been part of this work over the years. Jim Masterson at the bottom here helped do that Google Earth flyover. And of course, Brian Cousin, our videographer, really helped a lot put that video together for you today. So with that, I just want to say you can help support our program here at Harbor Branch by purchasing a Save Our Seas plate. Just $25. It doesn't sound like much, but if all of you purchased one, it would make a big difference. And a few last shots, those archive shots I was talking about earlier. Okay, check it out. This is me on the beach at Hyannis. The very year John Ryther published that paper. Look at that. Here I am, 83, when I'm writing my proposal. I've had seaweed on the brain for a long time. And this past year, the studies continue, and stay tuned. We got more secrets coming. Thank you, and I'll be glad to answer some questions if you have some.